In the middle of the Arizona desert sits the largest collection of military aircraft on Earth. 4,000 planes spread across 2,600 acres of sun-baked terrain. F-14 Tomcats that defended carrier battle groups. A-10 Warthogs that provided close air support in Iraq. B-52 bombers that flew during the Cold War. Each aircraft represents millions of dollars in taxpayer investment, decades of engineering development, and countless hours of combat operations. Yet they sit in neat rows under the desert sun, seemingly abandoned and forgotten. The total value of aircraft stored here exceeds $35 billion. Why would the military abandon this much combat power in the Arizona desert? The answer reveals a strategic capability that most people never consider. Welcome to FlightDeck. Today we're exploring the 309th Aerospace Maintenance and Regeneration Group facility at Davis-Monthan Air Force Base, and why this aircraft boneyard represents one of America's most valuable military assets rather than a collection of abandoned junk. The first question everyone asks when they see satellite images of this facility is simple: why Arizona? The military could store retired aircraft anywhere in the country. Yet they chose this specific location in the Sonoran Desert for reasons that go far beyond available land. The decision reveals sophisticated thinking about materials preservation and long-term aircraft storage. Arizona's climate provides nearly perfect conditions for storing aluminum aircraft. The average humidity in Tucson measures below 30% year-round. Rainfall totals less than 12 inches annually. These dry conditions prevent the corrosion that would rapidly destroy aircraft stored in humid environments. An F-16 stored in Florida would develop significant corrosion damage within months. That same aircraft in Arizona can sit for decades with minimal degradation. The alkaline soil at Davis-Monthan provides additional advantages. Unlike acidic soils that accelerate metal corrosion, the desert hardpan creates a stable surface that supports aircraft weight without extensive concrete. This reduces infrastructure cost while providing solid parking that doesn't trap moisture against landing gear and airframe structures. Temperature stability matters more than most people realize. While Arizona experiences extreme heat, the lack of freeze-thaw cycles prevents the expansion and contraction damage that affects aircraft in colder climates. Hydraulic systems don't experience the stress of repeated freezing. Fuel tanks avoid the cracking that temperature cycling causes. The consistent heat actually preserves systems better than moderate climates with greater temperature variation. But calling this facility a boneyard or graveyard fundamentally misunderstands its purpose. The 309th AMARG doesn't simply store dead aircraft waiting for scrapping. It operates as a strategic reserve, parts depot, and aircraft regeneration center that provides capabilities no other facility can match. Think about what happens when the military needs additional aircraft quickly. Building new fighters or bombers requires years of production time and billions in manufacturing costs. But pulling stored aircraft from Davis-Monthan and returning them to service takes months instead of years and costs a fraction of new production. During the Gulf War, the Air Force regenerated B-52 bombers from storage to meet increased operational demands. Those aircraft flew combat missions within months of leaving the desert. The aircraft stored here fall into different categories that determine their future. Type 1000 storage means long-term preservation with potential return to service. These aircraft receive extensive preparation, including fuel system preservation, engine protection, and cockpit sealing. Maintenance crews can return Type 1000 aircraft to flying condition within months. Type 2000 storage indicates parts reclamation aircraft. These planes will never fly again, but they provide spare parts for active fleet aircraft. When an F-15 in service needs a specific component, maintenance teams can harvest that part from a stored aircraft rather than manufacturing a new one. This part's availability keeps older aircraft flying years beyond their planned service life. Type 3000 storage means aircraft awaiting disposal. These planes have reached the end of useful life with no remaining parts value. But even disposal follows careful processes to recover valuable materials and prevent technology from reaching adversaries. The regeneration process reveals engineering capabilities that most people never see. Taking an aircraft that sat in the desert for a decade and returning it to combat-ready status requires systematic work across every aircraft system. The process begins months before the aircraft moves from its storage location. Engineers assess airframe condition through detailed inspections. Corrosion gets treated and repaired. Flight control surfaces receive lubrication and function checks. Landing gear undergoes complete servicing. Fuel systems get flushed and tested. Hydraulics receive new fluid and seal replacement. Every system must meet the same standards required for active service aircraft. Engine work presents particular challenges. Turbine engines can't simply sit for years then start immediately. The regeneration team removes engines for complete teardown and inspection. Bearings get replaced, seals renewed, and combustion sections evaluated. After reassembly, engines undergo extensive ground testing before installation back on the aircraft. Avionics systems require updates to match current operational standards. Radars that worked perfectly when the aircraft entered storage may be obsolete by current standards. Communications equipment gets upgraded to maintain compatibility with active fleet aircraft. Navigation systems receive GPS and data link modifications. The cockpit might look identical externally, but internal systems get modernized to current specifications. The final step involves extensive flight testing. Test pilots put regenerated aircraft through complete flight profiles to verify every system works correctly. If problems emerge, the aircraft returns for additional work until it meets all performance standards. Only then does a regenerated aircraft transfer to operational units. The parts reclamation mission provides value that exceeds even the regeneration capability. Modern military aircraft operate for decades, often 30 to 40 years from initial production. Manufacturing runs end long before aircraft retirement, creating spare parts challenges that stored aircraft solve. Consider the F-14 Tomcat. The Navy retired this fighter in 2006, ending a production run that stopped in 1992. But many components from F-14s remain useful for other aircraft that share similar systems. Engines, radar components, structural parts, and avionics from stored Tomcats support other aircraft still in service. The parts harvesting process follows strict procedures to maintain traceability and quality. When maintenance teams pull a component from a stored aircraft, they document its history, service time, and condition. This tracking ensures that only airworthy parts enter the supply system. Components get tested and certified before becoming available for installation on active aircraft. This part's availability provides capabilities impossible through new manufacturing. Some components no longer have production tooling. The original manufacturer may have closed or stopped making military parts. Even when new manufacturing remains possible, lead times can stretch months or years. Pulling parts from storage aircraft provides immediate availability at fraction of new manufacturing cost. The economic value of parts reclamation exceeds billions of dollars. Every component harvested from storage represents manufacturing costs avoided and operational aircraft kept flying. An active-duty F-15 that needs a specific actuator can get that part within days from Davis-Monthan rather than waiting months for new production. The strategic implications of maintaining this facility extend beyond simple cost savings. Davis-Monthan provides surge capacity that shapes how America projects military power globally. When crises emerge requiring additional aircraft, the stored fleet offers options unavailable to any other military. During the 1990s, the Air Force maintained smaller active bomber fleets by keeping additional B-52s in ready storage. If conflict required more bombers than the active fleet provided, stored aircraft could return to service within months. This approach reduced peacetime operating costs while maintaining wartime surge capacity. Foreign military sales benefit from stored aircraft availability. When Allied nations purchase American fighters, refurbished aircraft from Davis-Monthan often fill those orders faster and cheaper than new production. A country buying F-16s might receive upgraded airframes from storage rather than waiting years for new manufacturing. By controlling retired aircraft, the military ensures that sensitive technology doesn't leak to potential enemies. Environmental considerations make centralized storage and disposal more efficient than distributed retirement. Rather than each base disposing of retired aircraft locally, Davis-Monthan handles all processing through standardized procedures. Hazardous materials get properly removed and disposed. Recyclable materials get recovered systematically. The environmental impact of aircraft disposal concentrates at one facility with proper controls rather than spreading across multiple locations. Walking through the storage areas reveals unexpected details about how aircraft preservation actually works. The most visible feature is the protective coating covering cockpit windows and other sensitive areas. This sprayed-on material called spray-lat shields glass and instruments from sun damage and wind-blown sand. When aircraft need regeneration, the coating peels away easily without residue. Engine inlets and exhausts receive covers preventing birds, insects, and debris from entering. Even small foreign objects can cause tremendous damage to turbine engines. The covers also keep moisture from condensing inside engines during temperature changes. Tires get special attention during storage preparation. Rather than leaving aircraft sitting on landing gear that could develop flat spots, maintenance crews slightly overinflate tires and periodically move aircraft to redistribute weight. This prevents the permanent deformation that would require complete tire replacement. Flight control surfaces get locked in neutral positions to prevent wind damage. Arizona does experience high winds that could force control surfaces to their limits repeatedly. Locking controls prevents this constant movement from damaging hinges and actuators. Fuel systems receive preservation treatment before storage. Simply draining fuel isn't sufficient because residual fuel leaves deposits that could clog lines and valves. The preservation process flushes systems with special compounds that prevent corrosion and keep internal passages clear. The human expertise required to operate this facility exceeds what most people imagine. The 309th AMARG employs specialists in every aircraft type stored on the property. These technicians understand systems for fighters, bombers, transports, helicopters, and specialized aircraft. Their collective knowledge spans decades of military aviation history. When the military needs a stored aircraft regenerated, these experts know exactly what that specific model requires. They've worked on dozens or hundreds of similar aircraft. They understand common problems, critical inspection points, and efficient regeneration procedures. This institutional knowledge makes regeneration feasible where it would otherwise be impossible. Training new personnel requires years because the diversity of aircraft creates enormous complexity. Someone who knows F-15 systems might need months learning F-16 differences. Bomber specialists have completely different expertise than fighter technicians. Transport aircraft require knowledge distinct from combat aircraft. Building and maintaining this expertise base represents strategic capability that can't be quickly replicated. So why does the military abandon thousands of fighter jets in the Arizona desert? Because they're not actually abandoned, they're strategically stored in the only climate that preserves aluminum aircraft for decades. Because this facility provides surge capacity enabling rapid force expansion when threats emerge. Because parts harvested here keep active aircraft flying years beyond their planned service life. Because regeneration costs a fraction of new production while providing combat-ready aircraft in months instead of years. The 309th AMARG represents sophisticated thinking about military capability and resource management. Rather than viewing retired aircraft as waste requiring disposal, the military recognizes their continuing value as strategic reserves, parts sources, and regeneration candidates. The $35 billion in stored aircraft provides capabilities that no amount of money could quickly replace. What surprised you most about the aircraft Boneyard? the regeneration capability, the parts reclamation mission, or the strategic reserve function? Let me know in the comments. If you want more deep dives into military aviation operations and capabilities, subscribe to FlightDeck. Until next time, remember that what looks abandoned in satellite images often represents carefully managed strategic assets providing capabilities invisible to casual observers.